as I said, I started in 2011 in the UK. Our presenters there were from ARM, ST, Ericsson, and Infineon. And we asked them to present their top 3 challenges. Already we began to see some level of commonality between the companies. So Brian Dickman, who is the verification lead across ARM globally, commented on complexity, as did a few others, complexity being their biggest challenge. And this is the one from Infineon, which I think sums up very well how quickly our industry is moving. This was Clemens Müller, who runs the verification methodology group in the automotive sector for Infineon. And you can see there that the complexity between 2006 and 2011, when he made his presentation, I guess is more than double within those 5 years. From 30 to 40 IPs to over 80. The number of CPUs is growing hugely at the moment. So I guess it's good news for ARM. But I guess we've all seen this because of the issue with clock speed, that we can't continuously increase clock speed. So the solution to not being able to increase clock speed is to put more CPUs on. And you can see this here as we go from 1 CPU in 2006 to 6 in 2011 to 16 in predicted 20 in 2016. Okay. So the chips that we're making are becoming much, much more complex. I think what we've seen in the design world is that people are rising to this challenge with IP reuse. So you can now go and buy from any of the vendors today. You can probably go and buy from them a USB design, or you can go and buy a PCIe design, or you can go to ARM and get as many CPUs as you want from ARM, and then the designers can put those together. But the verification challenge increases hugely the more IPs you've got, the more the way you integrate those together. So I think as the IP reuse grows, it's becoming easier for the designers, but still very complex for verification engineers. And we do some, Mentor did a very good survey of verification challenges as well. And verification reuse hasn't had as big impact so far as IP reuse. So design IP reuse is a much bigger efficiency gain than we have from verification IP reuse at the moment, according to the statistics. Another one was scalability. This is the slide from ARM on scalability. It plays well into what we were hearing earlier about FPGAs. We were working with ARM quite extensively, and what they wanted to do, their challenge was really to run at least the equivalent of 2 weeks real time on a CPU before they shipped it. Okay, I guess the shipping ARM is just releasing the RTL to their clients or their licensees. And this is what they calculated in order to be able to run for 2 weeks. So if their CPU is running at 1 gigahertz and they want to run for 2 weeks equivalent, that means they need 0.6 turns, 2 to the 10 to the 15 cycles to do that. And that's just a huge challenge in terms of, I don't think you're not seeing some of the colors on there very well. No. Sorry, the projector's not working very well by the looks of things. This is the this is emulation. This is simulation here. So ARM have a big farm with 1 million simulation slots in. Okay, but that would give them an achievable cycle of 10 to the 11. 1,000 emulation slots would take them up to 10 to the 12. 100 FPGA slots would take them up to 10 to the 14, and 1 chip would get them to the 10 to the 15. That's how the number of slots and the amount of simulation or emulation they need to achieve 2 weeks at target speed of 1 gigahertz. Okay, so I know ARM invests a lot of money into, first of all, their simulation farms. They buy a lot of emulators, not 1,000, but they buy a lot of emulators. And as we've heard today as well, they invest a lot in FPGA. So they're finding it very hard to scale the simulation capability with the complexity of the designs they're making. Also, by the way, this is why I think ARM are investing a lot of effort into formal verification as well. They see they see this as never going away. With the increasing complexity, always chasing simulation cycles is probably a problem you cannot solve through simulation alone, which is why they've invested a lot in formal verification. I know they're a big customer with Jasper as well, so it's now part of Cadence, obviously. Resources. This is a UK issue, I guess. We have a lot of resources in India, but finding good verification engineers is always difficult. No matter how big the resource pool is, finding good verification engineers is always very difficult. I guess we expected UVM to make it easier to go into the marketplace to find good engineers, but now SV UVM verification engineers are in great demand and attracting good salaries as well. So it should make it, one thing that SV UVM does do is it should make it easier for engineers to move around the industry. So now when somebody arrives in your company, if you're using SV UVM, the training cycle is usually a lot shorter because they understand the methodology and the test benches you're writing. We heard from mixed signal this morning. Mixed signals, again, comes up quite a lot in Europe. And the reason here is the boundary between analog and digital is fading fast. We're putting a lot more analog onto our chips now. And normally, as in all verification and all the chips we make, the bugs normally come at the boundaries. It's normally the boundaries between blocks, or quite often the boundary between human beings. So in your design process, where there's a boundary between human beings and there's a possibility for communication problems, that's quite often where you find the bugs. And with human beings, the boundary between digital and analog become the problem. Okay. And power, low power is also an issue for mixed signal people. Did I miss a slide there? No. Okay, so 2012, we were in France. We had ARM, again, Laurent Arditi, who's a formal verification expert, Thomas Gust of ST Ericsson, which is now gone, of course, Jean Bemar of TI, and Christophe Chavalaz of ST, who was the verification methodology group led. And he was talking about verification data management. As you can see from the slide from ARM, we're running more and more simulations, we're running more and more emulation, running more and more FPGA, doing more and more formal verification. And what it does do is it creates a huge amount of verification data. Okay, and the only reason you want that data is to be able to make a decision. Okay, the only reason for having lots of data, if you can turn that data into information which allows you to make a decision. And SD highlighted this with their verification management. How can they actually get all this data and from that data make a decision about, are we ready to ship? Okay, so binary, at the end of the day, normally it's a binary decision. Are we ready to ship or not? It's a yes or no decision, but you've got huge amounts of data to help you make that decision. And how do you manage that data? Okay, how do you get it all into one place? And then how do you actually allow somebody to sift through that data and make an intelligent decision based on that data? ST have been building a MySQL database which allows them to do searches of their data. So they try and get all the data from all the sources into a single SQL database which allows them to do searches and then do business intelligence tools. The data they use is also for management of the project. So at the end of the day, you do want a yes/no decision on on whether to ship or not, but throughout the process, you want the data to guide you on your verification closure and how far away you are from tape. So they have two reasons for that data. One is to manage the project more effectively, and one is to make the decision at the end of the project on shipping. In 2012 in Germany, Lantic, Freescale, and Infineon, requirements-driven verification. This is becoming more and more prevalent, especially certainly for Infineon or in the automotive domain. But anybody working in a safety-related domain, normally now there's some sort of standard which guides how you do your verification. So, for example, in automotive, it's ISO 26262. In avionics, it's DO 254. And part of the standard says that you have to do requirements-driven verifications. This is becoming more and more popular now, certainly within Infineon. How do you map all the verification you do onto the requirements of that chip, so that at the end of the day you can understand that every requirement has been properly verified, especially with safety requirements. If the requirement for the chip has anything to do with safety, it's safety related in any way, then you have to verify, well, you have to demonstrate that that requirement has been properly verified. And therefore you have to do traceability from requirements all the way down to functional coverage or code coverage or properties. And again, that gives has another impact on verification data management. Okay, and then with the number of chips going into cars, the number of chips going into planes, this will probably become a bigger issue, certainly for those industries, avionics and automotive. In India, last year, we had NXP, MaxLinear, and ARM. And then I'm just going to go through quickly now so we can get to Amit's presentation from Synopsys. So these were presentations from Europe last year. Okay, and here's all the summary of, as I say, about over the past 3 years, we're now into our 4th year of verification futures. Here's a summary of the top challenges we've had. Complexity we've looked at. This one's becoming more and more of an issue now for people. Integrated languages, views, and techniques. So if you speak to people possibly migrating to UVM, System Verilog UVM, they have a lot of legacy. So they may have SpecMan environments, they may have Verilog environments, they may have Vero environments. What they don't want to do is just throw everything away because UVM is now the latest flavor. So you somehow have to find ways of integrating all your languages and views and techniques into one place, So the test benches are becoming complex because you may have SpecMan, Vera, Verilog, System C, System Verilog, 5 potential languages in one test bench, especially at SOC level. Okay, and finally, there's the whole list of so there'll be. I won't go through that now because there's a lot of data there. But normally, you can, within your organization, you can try and find your top 3 challenges and find them somewhere on that list. You'll find that other companies are probably facing the same challenges.